What's up, guys? This is Jahangir from Edporium, and today we're going to be starting off our physics unit. Now, physics is one of the most complicated topics that us pre-meds have to go through. And starting off physics, I want to talk about vectors and scalars. So this is one of the easiest topics to understand in physics, and this is actually the basis for understanding kinematics, force diagrams, and other things in physics. So first off, let's find the difference between a vector and a scalar. Now, a vector is going to have two characteristics that makes it very special. They're going to have both magnitude, so this is our numbers, so magnitude. Magnitude is basically how much of it there is. So for example, if we were talking about velocity, which is a vector, which we'll talk about one of the other characteristics why, a magnitude of that would be 3 meters per second. So it's that number that we're talking about, and that's the magnitude. Now it's going to have magnitude and direction. So direction. And this is what makes vectors very special, because they have magnitude and direction. And these include things like, let me change the color over here. This includes velocity, and displacement. So velocity is going to be a change in displacement over time, while displacement is going to be a change of a position over time. So both of these are going to be changes, and velocity is going to be speed but with direction. So with speed is going to be a scalar. So a scalar is just going to have magnitude. So we'll put only magnitude. So it's only going to have a value like 3 meters per second. And our examples for this are speed, and distance. Now, since scalars don't have a direction, they're mostly going to be positive, which is why we never have a negative speed, because speed never has direction. It's only velocity that has direction, which is basically speed but with direction. So velocity, our equation for velocity, and you're going to see this many times in your formula sheet or just in physics in general, it's going to be change in displacement over change in time, while displacement is just going to be this change in x, which is our position. So distance over here is just going to be x. So distance is just going to be x over here. Now velocity and speed, the differences between the two are pretty easy, because velocity can be positive or negative because it has a direction while speed doesn't. But displacement and distance could be a little bit difficult to comprehend at first. So it's something like, let's say we had a distance of, let's say we were walking from point of origin. So we started off here and we move all around here, move around in circles, and we end right here. So we start over here, so I'll just label this as start. So S is just representing start, F is just going to represent finish. Now our total distance is this entire area of what we walked through, but here's the thing. Our displacement is going to be a change in position. It's basically our final position minus our start position. So our displacement is actually going to be something like this. So this is our displacement right here, where it's going to be that change in our final minus our initial. That's the difference between displacement and distance, where displacement is a change in our position and distance is just how much position we've covered. Doesn't matter if we went in these loops or anything like that. Distance is the total amount that we walked through. Now, here's another thing to understand with displacement and distance. So I'm going to give you guys a quick practice problem. I'm going to ask you guys, if we're running around a track, let's say we started from here and we run all the way around, what is our displacement? We know our distance is going to be all this blue, but what would be our displacement? Now, if you said our displacement is 0, you'd be correct. The reason why is because we started and finished at the same position. Since we did that, we didn't really change in position because we're at the same place we started off. So that means our displacement is going to be 0. That's one of the things you have to understand. Even though we ran across the entire track, our displacement is 0. And since displacement is 0, our velocity would be 0 as well. Now, in a real life example, or just thinking about velocity in terms of just regular language, you might think that that's impossible because you're still running, you must have velocity. But we're looking at equations, we're looking at the raw physics, and physics is showing us that since we started at the same position and we finished at that same position, so it's somewhere maybe right here, our displacement is going to end up being 0. So that might be one of those questions that might trip you up, just those conceptual questions. So always have faith in these equations. Even though we covered a lot of distance, displacement is going to be 0 because displacement depends on where we started off and where we finished. Now, talking more on these vectors, vectors are usually going to be shown as just straight arrows, maybe on a graph or anywhere else, and we'd represent it by some letter with a arrow on top. So maybe something like this, and we might see, let's just say we had a anti-parallel vector over here, and this might be something like B over here. So two vectors will only be equal if their magnitude and direction are the same. Now, both of these magnitudes are pretty similar, and you'll actually see in maybe your multiple choice questions or pretty much anywhere around the exam, it'll say something like 2a or 3b. It'll tell you the scale at which those vectors are, that magnitude. Because just looking at these vectors, you can't really say what their magnitude is unless they're on a graph and they have values on that. So these are our vectors. Now, since these are anti-parallel, they're both in different directions, they pretty much cancel each other out since they're both the same magnitude but different directions. So they pretty much cancel each other out. And just to write this as our equation for calculating vectors, our equation for that is a plus b is going to equal our magnitude of vector sum. So this C over here, and I'll write this in a different color, is going to be our magnitude of vector sum. So this is the magnitude of our vector sum, and it's going to equal pretty much all the vectors we have. Now, since our b vector is in a different direction, then our b vector is going to be a negative number. So it's going to be a minus b vector, and this is going to equal our magnitude of vector sum. So when you see these vectors in opposite directions, you always need to put a negative for those vectors because they're pretty much in the opposite direction. Now, you could also, I just wrote that in a simplified way, but you could also write it as this. So this is basically showing that our vector b is in a different direction. That is why we have a negative sign beside it, indicating that it is in a different direction, an opposite direction. So that is the only part of sort of direction you need to understand, is that if it's an opposite direction, we put a negative sign. And it depends on which one we correlate as our positive direction. We could have also said that B is our positive direction and A is on the opposite, so A could be negative. It doesn't really matter which one we label positive or negative. As long as we know which one is our positive direction, anything against that direction is going to be negative. So let's look at some other examples for calculating vectors. Now, if we had something like an A vector over here and a B vector over here, and this isn't drawn on the scale, let's just assume that they're both the same magnitude, same direction, we're going to be adding them up. Different direction over here, we're going to be subtracting them since one of them is in the opposite direction. So that's a really easy thing to understand about those vectors, is that first we need to understand which one is going to be our positive direction, either left or right. Doesn't really matter. Then once we do that, then anything against that or for that, we add, we subtract, or we add respectively. So now that we understand that, and now we know that this is our prime equation we need to be looking at, let's go through a practice problem real quick. So Let's say that you walked, let's say you walked 40 meters east. So 40 meters east, then 30 meters north. So if you walked 40 meters east, 30 meters north, what is your displacement? Displacement. So before we do anything, one of the key things you need to do for any of these word problems in physics is that you need to draw it out. This is the best way to understand it from a visual standpoint, because usually with these word problems, they're going to have some sort of diagram or some sort of thing you need to draw in order to illustrate what the question is asking. If that didn't really make sense, let's just draw it out real quick. That's pretty much what I meant from that. So if we're walking 40 meters east, east is going to be over here. So let's just say this represents 40 meters. Now, when we walked 40 meters, the question is saying that we went 30 meters north. So this would be 30 meters north. So now it is asking, what is our displacement? So pause this video and see if you can solve this problem. So we know that displacement is from start over here to finish over here. So our displacement is going to be this area right here. This line right here is going to be our displacement. This is exactly what we're looking for. We're looking for displacement, which we can write, symbolize as this A. So if you use the Pythagorean theorem to answer this question, you'd be right, because this is a right triangle. And since we have a right triangle formation, then all we have to do is use Pythagorean theorem. If you guys don't remember, Pythagorean theorem is c squared equals a squared plus b squared. So we have our a, and we can just say a is like 40 meters. Doesn't really matter which one we put, a or b. It's interchangeable. So this is going to be 40 squared plus 30 squared, and that's going to be 2500. Now you have to square root that, which is going to be 50. So our displacement over here is going to equal 50 meters. So that's just one of the things you have to know, and this is just from past trigonometry. If you don't remember those trig functions and pretty much most of trigonometry, then you're going to have this right angle. When you have that right angle, your theta is going to be somewhere over here. That's what we're assuming, because most of the time we're going to be looking at some of these graphs where we just put theta on this side, but you could put theta on this side as well. It doesn't really matter. One of the things you have to know is your trig functions. Throughout physics, you just have to know your trig functions. So we have sine theta equals opposite over hypotenuse. I just abbreviated. O is opposite, H is hypotenuse. So in this example right here, our opposite would be 30, our hypotenuse would be 50. So for this example right here, sine of theta equals, and let me do this in a different color, 30 over 50 for this example specifically. Because looking at our theta, the opposite is 30 meters and the hypotenuse is 50. And let's just go through a couple of the other trig functions. You also have cosine theta, which is going to be adjacent over hypotenuse. And this might be a refresher to some of you guys. And we also have tangent theta, which is going to be opposite over adjacent. And since we know tangent is also equal to cosine theta over sine. And our last one that we have to know for physics is, and I'll just write it over here, it's sine squared theta plus cosine squared theta equals 1. So that's pretty much the only big trig function we have to know. But these are the main ones that we have to know for physics and understanding these vectors, scalars, as well as just kinematics in general, which we'll get onto in a future video. Now, one tip I'd give to you guys is when you're doing these scalar questions, more than likely they're going to be giving you a graph, something like this over here. So we might see a graph like this, and let's say our vector was something like this. And this vector is obviously representing our hypotenuse. Now, since that represents our hypotenuse, then we could write both of our lengths. So you could write it in different ways. You could say that this is your y over here, this is your x, or you could say this is your x, this is your y. Whatever works best for you, but what works best for me is looking at this part over here. So I'm just going to erase this. So usually when I see these vector questions, I always write my x and my y to the right of the hypotenuse. It just makes it easier to understand. And once you do that, your theta, and like I was talking about, your theta is usually going to be on your left if you do this. So your theta is going to be, so this is going to represent your theta, that angle. And looking at this chart over here, you're going to have many different angles, but basing it over here is the best tip that I can give you guys for understanding these vectors. And we just said that this big yellow line over here is our displacement. So since we know that's our displacement, and let's just say we were given theta, our y-axis over here would be, and we'll just say AY is going to equal our displacement times sine of theta. The reason why is because our theta is opposite over adjacent. So we know our sine is, or sine theta is going to equal opposite over adjacent, or opposite over hypotenuse, my bad. So opposite over hypotenuse, which is going to be our displacement. If we just multiply this on the other side, so we multiply this over here, multiply this over here, then this is pretty much what we get. You can also say that this is the opposite, so that's just manipulating the equation towards our benefit. So since our y-axis over here, that opposite side is going to equal a sine of theta, our displacement sine theta, then over here it's going to be displacement cosine theta. And obviously since this is adjacent over hypotenuse. So if you're given your displacement, you're given your vector over here, you also have your degree, your theta, then you could find these sides pretty easily. And if we're looking at this example over here, our Pythagorean theorem is just the same, but we're just going to manipulate it and put different variables. So it's still c squared equals a squared plus b squared, but we're going to look at ax, ay, which is going to represent our a and b in the Pythagorean theorem, and this a displacement is going to represent our c. So if we do that, our displacement is going to equal ax squared plus ay squared, and then that's square rooted. This is literally just Pythagorean theorem, so don't get confused on this. It's just Pythagorean theorem. I just put the square root and change the variables. So this is one of the equations that we need to keep in mind going through all these practice problems that we're going to do, as well as knowing that theta is going to also equal tangent inverse of ay over ax. So tangent inverse is another one of those things you need to understand, and we make it inverse so that we can move this tangent, which was over here. So tangent was over here, but if we want to move it over here, it's just tangent inverse, which is literally just 1 over tangent. So we just divided tangent over to the other side in order to get our theta, if assuming that we were looking for our theta. So these are just manipulating your equations, and that's one of the biggest things you need to be like pretty much a master at in physics. Because when you go through kinematics problems, when you go through force problems, and even further on we're going to go through circular motion and springs and whatnot, you need to be able to manipulate these equations or correlate them to different equations. It's going to be one of the biggest skills you need in AP Physics, is correlating these equations to each other or manipulating it towards your benefit, which is literally where algebra comes into play. So this is the basis for us to understand our practice problems. And now let's get into our practice problems. Alright, so let's look at this practice problem real quick. So it says Paul walks AX east and AY north, making him 50 meters away from the origin at 35 degrees northeast. Now this AX, AY, these are variables that we don't know. And Emily walks BX west and BY south, making her 700 meters away from the origin at 55 degrees southwest. So now it's asking us to find our AX, AY, BX, and BY. So let's start with Paul real quick, and let's just sort of visualize what Paul's distance looks like, or where he's really walking. So first off, we want to draw our graph. We want to draw our just normal generic graph over here. So this is just up here. So we have this graph, just our generic graph that we're drawing over here, and I'm going to make this a little bit more bigger so we can see it better. So let's just say we had something like this, and I'm going to label Paul's sort of displacement diagram, whatnot, as just yellow. So Paul is going to represent the yellow lines. So Paul walks AX east. So since we're walking AX east, we're walking over here. So this is AX. And we're also walking AY north. So we don't know these values, they're just variables, but we're just writing it out just to visualize it. And we know that, we see that. So now we see that he's 500 meters away from the origin. So this is origin, this is how far he's gone. So we know that our hypotenuse is going to be 500. So our displacement is going to equal 500 meters. And we know he's also, our theta, 35, let me actually write this better, 35 degrees, and he's 35 degrees northeast. So we know that. Now the question is, how do we find our AX, AY? If we look back at our equations over here, our AX equals AX cosine theta, our AY equals A sine theta. So all we have to do is our AX is going to be, and I'll just put an arrow right here just to represent AX. It's going to be 500 cosine 35, and over here our AY is going to equal 500 sine. Oh, and make sure when you're doing your math, you go on your TI-84, you go to mode and you put degrees, because we are looking at degrees. If we were looking at radians, then you'd put it at radians, but that's just one thing to note, because when I was trying to make this video, I put in radians and I was so confused of the answers that I was getting. So we have 500 cosine 35, and that's going to equal, and I'm just going to round over here, this is going to be 410 meters. Our AY over here, I'm just going to partially erase this over here so we can have room to write our answer. AY is going to be 500 sine 35, and that's going to be, if I round that up, it's going to be 287 meters. So we just found our AX. We just found our AY. Now we need to find BX, BY. So we just do the same exact thing, and I'm just going to represent Emily as blue over here. So Emily is going to represent our blue lines. So we know that we're let's just say this represents 700. So we have 700 meters right here. Let me actually do this. 700 meters right here. This is going to represent our hypotenuse. So we know we're moving BX west over here, and then we're moving BY south. So this is going to represent our BX over here. This is going to be our BY. And over here, now this is one thing to note. They did tell us that the degrees that she's southwest, 55 degrees southwest. But this is one thing to always remember. This is actually the biggest reason why we wrote on graph, is that although it's saying 55 degrees, we have to correlate our degrees from this origin over here, that x-axis over here, 0, all the way around over here. So instead of 55 degrees, this is going to be 180 plus 55. This is going to be 235 degrees. Actually, let me write that a little bit better. 235 degrees. The reason why is because if we look at this graph over here, this degree over here, just looking at this, that's not 55 degrees. If we're just looking at a plain graph and we want to look at where 55 degrees is, 55 degrees is somewhere over here. Now, we're saying 55 degrees, but that's southwest. So you always have to correlate your degrees based on this x-axis 0 right here and move all around. If we had something like this over here and this said 45 degrees southeast, that still means that we have to get 270 plus 45, which gets us our degrees over here, which is 315. So always remember that you have to correlate your degrees, that when you're calculating, you have to correlate your degrees corresponding to that positive x-axis, starting from 0 all the way around. So once we know that our theta is actually 235 degrees. So pretty much the same concept over here, where our bx is going to be our cosine. So this is going to be 235 cosine or actually, my bad, it's supposed to be 700 cosine 235. And over here, our by is going to be 700 sine 235. So I know my handwriting is kind of bad and kind of hard to read, but you guys get the picture over here. So actually, let me fix that. That's a terrible writing right there. That S looks too big. So we have sine right here. So 700 sine 235, 700 cosine 235. When we do that, we'll do the cosine first. 700 cosine 235. We're going to get... Now, you will see that you're going to get a negative number, but this is only because we're in the opposite direction. Because we're saying that east is our positive direction, so west is a different direction opposing it, so it's going to be negative. So this is saying that we're negative 401 meters east, which literally just means we're 104 meters east. So you could forget about that negative sign because we're looking at distance over here. We're not looking at displacement, because if we were looking at displacement, then we would have said that if we were corresponding to 500 as positive, we would say this would be negative. But you can forget all that because we're looking at the distance of bx, which is just west. And west, we've walked, or Emily has walked 402 meters west. So our bx is going to be 402 meters. So now we do our 700 sine 235, and that's going to be negative 573, which is just going to be 573 meters south. So this is exactly how you find your opposing lines like bx, ax, by, ay. It's just using these equations of our displacement times cosine theta or sine theta. Alright, so that wraps up our video on vectors and scalars. Now hopefully this all made sense, because this is the math portion of vectors and scalars, and knowing this really helps you understand the things in kinematics and other topics in physics, especially these algebra questions. Now that's all for me. Hopefully you guys learned something. As always, a Pomodoro day will make you a doctor someday. I'll see you guys in the next one.